welcome to the DecentraWise Podcast. My name is Pedro.
And I'm Miguel, and you just joined us in our mission to decentralize the world wisely.
Decentralizing the world. It has been quite a journey, hasn't it,
Right?
Miguel?
Oh yeah,
A few years doing
a few.
crazy stuff. A few? Yeah, almost 10 years, man. This is crazy.
Yeah, around that. Yeah.
Anyway, today we have a cool episode. Another request from our viewers, and shout out to Victor.
Yeah, shout out to him.
Man, really cool idea. And let's dive in. But first, as always, grab your coffee or
Yeah,
any
I
other
got it here.
drink. You can do absinthe if you want, or alcohol for
Yeah, it won't help you
medicine
keeping you
stuff.
awake. Yeah,
Anything
it
you
doesn't
like to
help.
drink.
Yeah, but it doesn't help you keeping you awake during the episode for sure.
Yeah.
But yeah, if
My
it's your stuff,
My little kid likes to drink vinegar, so anything counts. So no problem.
yeah. Regarding that, guys, don't forget to press the like button and subscribe if you're enjoying our episodes. It helps us a lot propagating our ideas.
Propagating. We are like a virus.
Yes.
We propagate.
Yeah, we
That's
just
what we
spread
do.
around people's computers and yeah, we propagate.
Exactly.
Yeah, well, it's what we do.
You could say reproduce. It would be much more fun.
Yeah, well, no, I'm not going to say that. I was going to say something. No.
Anyway, yeah, that's what we do. We do this kind of stuff.
We propagate.
We propagate. So,
okay, so today's subject is about being a core blockchain developer in 2024. So, what exactly is?
Yeah.
Yeah, just go ahead.
Don't forget that we are not repeating ourselves. Today, we are talking about core blockchain developers, okay? Because there are plenty of activities around blockchain development, right?
Yeah.
And being a blockchain developer can mean a lot of things. There are blockchain developers for front end. There are blockchain developers for smart contracts. There are blockchain developers for backends that interact with blockchains. There are blockchain developers that implement projects, like deploying them and creating the infrastructure, the DevOps kind of. And the strange guys we are talking about today are the core developers, right? The ones that do the core. So
yeah, let's specify that those guys that develop the blockchains themselves. So we are not talking about smart contracts. We are not talking about front ends. We are not talking about anything. We are talking about the blockchain and some specific crazy guys that do that development. They have to be really crazy.
The first crazy guy was actually Satoshi Nakamoto himself, or themselves, because I think it's a group of people. But anyway, they did the first blockchain, right? Bitcoin blockchain. And right now we have a core set of developers that continue to work on that blockchain, right?
Mhm.
So those are core developers of Bitcoin's protocol, right? And each blockchain have a set of core developers, like Vitalik Buterin in Ethereum and a bunch of other guys. Like in Polkadot, you have what's the name of the other guy? The guy that left Ethereum for Polkadot is Gavin Wood, right? And yeah, Cardano, the main guy is. I am terrible with names, guys. Don't forgive me because I have to think a lot to remember names. What's the name of the guy from Cardano, man? Help me out.
No, I'm not going to remember the name of the guy. Sorry.
You are worse than me.
No,
So
yeah,
yeah,
for sure.
that's
I'm good with faces, not good with names.
yeah. He was also in BitShares, one of the founders of BitShares One, um, Charles Hoskinson. I did it. Yes. So yeah, those are like engineers dedicated to mainly architecture and stuff, and then there are core developers developing the actual thing, right? uh, like Dan Larimer in BitShares and a bunch of other chains including EOS and all that. So um, being a core developer is to develop the blockchain itself, developing the protocol uh, codes that will run on the nodes, right? Or
Yeah,
developing the standards. Because, for instance, in Ethereum, um, the core developers first design the protocol and then implementations implement the design decisions, right? Like there is Geth, like the node code for made in Go. There is parity. There is a lot of nodes that implement the same protocol. So, but usually each blockchain have their own implementation. That's not a requirement to have a design uh, standards and then several implementations. Okay, so yeah, you have both of those. Being a core developer can be both of those things. Being more an architect kind of guy and being a developer or usually a senior developer, hopefully a senior developer
yeah,
developing the chain itself, right? And I'm not saying
yeah,
this with a bad um taste, because being a core developer in blockchain is a serious job, right? It's not something that a junior developer would do because it's very
yeah. You kind of need
it's too
to have some
risky.
expertise to have some expertise on the subject, and the issue there is that you need to pay attention to a lot of details, and it's not only that. Of course, it's the whole thing surrounding the blockchain concept that you need to be aware. And yeah, usually junior guys are catching up with the programming part, with the development, with the architecture details, and not the blockchain concepts yet. So it's a very specific world. It has a very specific set of standards to which a more senior guy would be more up to
The
manage
tasks.
that. Yeah.
Yeah. So developing blockchain code, like creating the nodes software, uh, requires a bunch of things.
Yeah,
Requires
let me before that. Let me start because For the ones that are not paying attention to our podcast, you should go
Are
to
there
previous episodes. And no, but
are
yeah,
there those
just
kind of
let's
guys?
pretend. Let's pretend there are people in this world that didn't
You are
see our podcast
imagining.
yet.
Okay.
Yeah, of
Okay.
course. Let's just explain very very shortly what a blockchain is and how it's composed. So a blockchain is it's a chain of blocks, like the name says. And the issue here is that each block is dependent on the previous block. So this is the
Except
basic thing, except the genesis block. So the first
yeah,
block is called the genesis block, and all blocks will have to born from that
derive
block,
from
so,
that.
or derive from that block. And then with this, every block is chained to the previous block, is linked, sorry, it's linked to the previous block. And this is the basics of a blockchain. There are a lot of things around this concept that we are going to go through during this episode, but this is the basics. So how they are linked is cryptographical. So the thing is that you have this genesis block, which goes along with some parameterization on the blockchain most of the times, if the blockchain is configurable or not. And
if in case of Bitcoin, encodes a message from Satoshi Nakamoto himself with a title of one news paper of the day that it was launched, right? Talking
yeah,
about the 2008 crisis and stuff like that. So yeah,
yeah.
the Genesis
This
block can include anything, right? Usually can include parameters, can include the initial state of the chain, like the accounts that exist, the balances that exist, or whatever.
yeah,
And then it closes it's enclosed in a block that has a header and that has the hash of the previous block, usually 0 because it's the first block,
yeah,
and then it's hashed, and that hash is put on the next block, and that's it. The chain of
yeah,
blocks is just that
yeah. That is the
link
link.
of the hashes from one block to the next block, right?
Yeah, exactly.
So
That was shorter than I did.
yeah, and continuing. So there is a chain of blocks, the code that it needs to implement the chain of blocks, and more.
Yeah.
Tell me.
So yeah, so having that, this is the main thing that a blockchain is composed of. Then we have other things that will constitute the blockchain, like consensus, governance, and all
Consensus
of that.
mechanism. Let's go there right
Do you
now.
want to go there right now?
Or no? You
No,
just
no.
want to
Okay.
go through them
Well,
all?
let's start from the beginning. Let's start from the beginning. So, usually blockchains, so that if people want to go into the core development of blockchains, what kind of languages are used when developing blockchains?
Well, usually the languages that we are talking about are very low-level languages, like C, C++, Go, Rust, that kind of languages usually. But
Yeah, and you say
the most
usually because there are even blockchains developed in JavaScript. So we found some stuff like
yeah,
that.
you can check Lisk, for instance. It's JavaScript blockchain. You can check Avalon, which is some other blockchain that we also worked a few years ago.
Yeah,
It's
and I'm saying this so that you guys don't get intimidated because you'll need to learn C or C++ or Rust or Go. You can use very standard languages like JavaScript and Python. I think there are some also. So you don't need to freak out just now and go along with it. You can start exploring blockchain development,
no,
even
but
though
actually, I
in
don't think
higher
it's a
level
bad
languages.
I don't think it's a bad thing to explore low-level languages.
No, of course not. But there are some people that will get kind of scared to go to lower level languages, and you can actually start digging out in a blockchain that it's in JavaScript, which is kind of easier than go into C or C++.
But don't intimidate yourself to try languages like Go, for instance, uh, or even C++. You just go as low as you wish to. You don't need to go all uh, to dive into the nitty gritty of pointers and memory allocation and all those crazy stuff.
Yeah.
Because all these languages have a lot of standards library functions that simplify a lot that low level part, right?
Mhm.
And I started developing in C and assembly and all those things. So that's as low as you can get, right? You cannot get any
Yeah.
lower than that. And I did the opposite route. So going from the very low level languages to the very high level languages. But the opposite is also true. And with the tools that we have right now, it's even easier because a developer starting in C++ can use C++ as Java or almost like that. Don't need to go too deep and learn bit by bit to get a little bit deeper. And yeah, and the code that I see in blockchains in C++ is very simple code. It's not very hard to understand, very low level code. What's hard in the blockchain development, uh, the core development, is actually to understand the cryptography around that, to understand security concerns, uh, to understand peer to peer networking, which sucks most of the time because it's a very unreliable network, to say the least, right? Because peers come and go, and the code needs to rely on unreliable connections,
Yeah.
and that's tricky uh, most of the times. Uh, those are the tricky parts, right? And to 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 use very high performance databases usually, because if you want to address scalability on your blockchain, Bitcoin doesn't have those requirements because with one block being released every 10 minutes, there's plenty of time to store shit,
Yeah.
right?
Yeah, but if
Uh,
you want a high performance blockchain, you need to have, and you are talking about high performance databases, and so you are talking about memory databases usually.
in high performance blockchains, yes, right. Not in Bitcoin. There's a memory pool that handles the ongoing transactions for the next block, and the rest is stored on disk, and the state is stored in memory, right? And in that's usually the same thing to all blockchains. Uh, you use the state in memory because the queries and the validation is already just validating signatures, and all that is time consuming enough. If you add more entropy to the process, like reading from disk and blah blah blah, that's too much, right? So usually the state is kept in memory, and uh, the blocks and all that is stored on disk. And if you want to have a real high performance blockchain, like graphene blockchains, which uh, we maintain, and we really like the design of those easily handle 100,000 transactions per second. Uh, Actually, the performance tests do 200,000 transactions per second.
Mhm.
So, and they have through the years in many implementations, in many networks, they have handled several million transactions per day
Yeah,
consistently. So if you compare that to Ethereum or any other layer one besides Solana, but Solana is crashing all the time, so I don't know if that becomes a reality or not, and anywhere soon. Uh, but if you compare to the other blockchains, that really uh, graphene's technology is ages uh, away from the performance that they achieve.
yeah.
And that's
Graphene was a pretty good
because,
technology that they put out.
yeah, that's exactly because the blockchain itself, the all the state of the blockchain is kept in memory, right?
Yeah,
And there is a database, a memory database that handles indexing and all those things uh, that is used to verify the states and verify the transactions and all those things and prevent from people to double spend their money, right?
yeah,
Or their uh, resources or whatever, because graphene chains don't just use money or balances as states, right? They have a lot of shit. Usually, they
yeah.
implement a lot of transactions. There are DEXs implemented in graphene blockchains. So, yeah, uh,
Yeah,
this
if you
is
want to have a node of that, you will need a huge amount of memory, of course, because as the state usage increases, you will the memory requirements also increase quite a bit.
that's another important things for a core blockchain developer. It's to use resources wisely, uh, because usually there are use cases where you really have to use state, blockchain state, to keep your data, right? But there are other places where you can store stuff if they are not needed to validate transactions, right? Uh,
Mhm.
that's one thing that was one of the very um, hard problems in Steam blockchain, for instance, back in 2017, 2016. Uh, they were the first blockchain for social media. For they had like a Reddit-like blockchain, and um, and Steam quickly uh, become very expensive to run nodes because they were storing all the data on the blockchain, right? So the content of the
Yeah.
posts. And if it would be implemented by me, uh, I would store on the blockchain the CID and store the content on IPFS. There are drawbacks. I know, right? If you have stuff on chain, it's there, it's immutable, no one can tamper with, blah blah blah. I don't care, right? Do, do I need the code, the the data of a post to validate anything? I don't, right? And it's up to the user to maintain their data. Doesn't have to be the nodes. Because the problem you have with that is the more state you have to hold, the more memory, as Miguel was saying, the node operators need to allow to run a node or to buy or to rent from a data center or whatever. And RAM is expensive, right? And if the token economics of your chain, which is another part of blockchain development, if the token economics don't compensate for that cost, or they compensate it until they don't, right? People are disincentivized to spend money to work, right? No one likes to spend money to work, right? And that's the problem. Usually, you want to have an healthy network of people contributing resources to your network, but they just contribute as long as the network itself allows them to. The people don't continue spending money if the network uh, don't compensate for their efforts, right? And that's natural. So if the costs of running a node become too expensive for the pay that the node operator receives per block, uh, why should they continue to support the chain, right?
Yeah.
That's the same with
Yeah,
Bitcoin.
work and investment has to be paid, or else nobody's going to do it.
Yeah, and the problem of
And let me just mention this
memory
because
consumption is that.
yeah, and let me just mention this because you really need a network in order to have a blockchain. And this is one of the biggest issues because you need a lot of nodes, and the more nodes that you have, the more reliable is this blockchain. Because you were talking about peer-to-peer communication and how unreliable it is, but it gets more reliable at the more nodes that you have. Because if you fail the communication with one node, you have I don't know how many others, depending on the size of the network. So the bigger that the network is, the more reliable the communication is.
Yeah,
So
and
you need to develop this network, and you need people to be there and invest on equipment. Like they need servers, they need an internal network most of the times, with more than one server. Sometimes it can go up to 4 or 5 servers with different characteristics and different roles. And this requires a lot of investment. We checked, like we did these nodes in EOS, and to get something working properly, it would require like 10,000 euro, $10,000 just to start
yeah,
up with to be a block.
a block
How did they
producer,
call that? Yeah, it
block
was a block
producer.
producer. Yeah.
Yeah,
So this requires money, and people are not investing this money not to get anything. So these block producers have to be paid, and it's a full-time job.
yeah. So there is the other part of being a core blockchain developer or architect, what you might call that. Um, you have to design something that makes sense economically, right? Usually, when you design a chain, there is a token economics. Usually, chains have tokens, right? Unless you are developing things like layer twos, like Base, which don't have an internal token, they use Ethereum. Uh, Usually, you have a token, and the token can be used for governance tasks and can be used for paying fees, for instance. Usually, is used for paying fees, but it's usually used for incentivizing the network as well. right? Like in
Yeah.
Bitcoin, why miners are paid to produce blocks? Because they have to actually spend money to be able to produce blocks, right? Their their value exchange is electricity, right? They spend electricity to once every n times be able to produce a block and receive their block rewards, right? And if they have to spend more money in electricity than the value of Bitcoin they receive per block producing uh, per day, for instance, um, if that continues and there is no change in that equation, then they're out of business soon, right? Because that's math, right? If
Yeah.
you spend more than you earn, uh, that's the natural result, right? So that is uh, an
Yeah.
economic balance that has to exist. That's why the halving is important in Bitcoin, and we are almost there. It's like 30 something days, right?
Yeah.
So uh, all these things need to be balanced, and it's very easy to uh, interpret this or that topic and get things wrong,
Yeah.
right? So that's another aspect of being a blockchain developer or architect in this case is to architect well the economic part of it. It's not just the technical, right?
Yeah. Okay, so if you want to become a core blockchain developer, you need to be aware of low-level programming languages. You need to be aware of cryptography, and another thing that is also usually embedded in the blockchains is are the consensus algorithms.
Hmm.
So the consensus is try to explain this also shortly, because you should also go and watch previous videos where we are talking about that more deeply. It's the way that blockchain decides what is right and wrong. So if there is something there is not well calculated or manipulated in a new block, there are thousands of other blocks saying what is wrong or right, and this is defined by the consensus mechanism. Do you want to go
Yeah,
through the at least the most used consensus mechanisms so that we can get a
there
grasp
are
of it?
there are a few aspects of that about that. The first thing is if you want to dig deeper in this, besides just going to watch our previous videos, you can also search for um Byzantine generals problem, right? That's the theoretical example of consensus reaching problem, right? Um, the problem here is that you don't have always a direct link between all nodes. Shit happens. Uh, network the internet has glitches. It's not that the internet is always on as you uh, expect it to be. No, uh, there are sometimes several hours of disconnectivity in the blockchain. Uh, believe it or not, uh, And for if you are on the wrong side of the planet, you maybe have a few days of uh, outage. And usually you have access to a part of the network, not the all. So that's that's an internet split, and that's not very uncommon. That happens a lot, and usually uh, in networks like this, you cannot rely that all the nodes have access to all the information all the time, and that's one of the reasons why blocks or nodes in the blockchain can be out of consensus, right? It's not just bad people doing nasty stuff. That happens a lot too, but
Yeah.
we'll go there after. Um, so, in a chain split, imagine that the connectivity between the Atlantic Ocean is cut for a few moments, right? The nodes that are in North America and Brazil and South America and blah 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 have the the consensus with the nodes in Europe and in Asia and in Africa um, until block N. But in block N plus one, the nodes in the um, Europe region and Africa and all that have a different reality than a different set of transactions that were sent to the mempool than the nodes on the other side of the ocean, right? So they will produce different blocks naturally because they don't know all the transactions and they are split. The network is split. So that's called what is called a fork in the network, right? Um, so right now we have two chains. We have one chain that is common until block N on both sides, and different on after the block N on side A and side B. And how can we just join these two networks? That's a problem, right? Now we have two realities. Which one is the truth, right? That's one of the things that Bitcoin white paper solves, um, and it's not like the Byzantine fault was solved. It's a mitigation of that reality. And the way we mitigate that is we evaluate the work needed on each side, on each fork. And the fork with more work is the one that is preserved, and the other fork is um, dis- disregarded. And they will have to undo all the transactions, see what transactions are already done in this fork, and resubmit the transactions again uh, to be added on top of the blocks that have more work. And what does that mean to have more work? In case of proof of work, is more hash power, right? So the
Mhm.
chain that was capable of producing more blocks is the chain that is valid, right? Because it's the chain that will be more wasteful to undo,
Yeah.
right? It's easy, and that is the way proof of work works. In proof of stake is a different thing. It's the work needed to evaluate which fork is more trustworthy is evaluated by the signatures from validators, right? The chain that has more signatures representing more stake is the one that is considered to be the true state, right?
Mhm.
And that's why the name is proof of stake, right? Because it's actually the stake involved in approving blocks that counts, right? So
Yeah. Yeah,
if you
that
consider
comes
that,
from
yeah,
the concept that people that have more skin in the game will make the decision, which is different from proof of work, and this is what distinguishes the most.
yeah, and this all these uh, ideas are what we called Byzantine fault tolerance, right? It's the way we tolerate a very tiny amount of possible failure, but since the outcome will most likely outgrow, uh, um, the truth will outgrow the little tiny possibility of failure, which is what we aim to, right? There is no way for us to solve the Byzantine generals'
Yeah,
fault. That's mathematical um, difficulty, right? And it has been for millennia. It's not
yeah,
us, right? So we need to mitigate that, and that's the way we mitigate is to find ways to where uh, the positive outcome will be much more likely than the negative one, right?
yeah. Yeah, let's just jump quickly to the delegated proof of stake. And the only difference here from proof of stake and delegated proof of stake is that users from blockchain users will just delegate that. It's like you are voting in an election for your favorite party. So you are delegating your power to a specific user so that that user will have enough power to take decisions in the blockchain.
Yeah,
So yeah, so consensus algorithms are just this mechanism to take decisions in the blockchain.
hmm
And this is also something that you should be aware if you are a core blockchain developer, is that these consensus algorithms are also embedded usually in the blockchains. Uh,
yeah,
re- Regarding other stuff, I'm going to jump here a couple of topics because I think it makes sense
yeah,
to talk about this. Let's talk about another embedded block that it's usually developed and it's usually embedded in the blockchain is the tokenomics of the main token and at least one economic model. Uh, Usually blockchains when they are created, as you were saying, they create their own tokens so that they can kind of manipulate some sort of economy. So do you want to go through that and talk a little bit about economic models and tokenomics?
yeah. Um, well, there are chains like Bitcoin which have a very simple token economic model, right? Bitcoin's tokenomics, as they say to save a few spaces between words. Um, uh, so it's very simple, right? You have a bunch of tokens, like 21 million, that are to be distributed during 100 something years, and uh, with the way they are distributed is um, it's an inverted uh, distribution, right? You start with, I don't know if it was 50 or 100 coins per block, and then you halve it every X amount of blocks, and
Yeah,
you
hence the
end up,
halving that you were talking about.
yeah. So, and that, why is that model? What Bitcoin wanted to achieve was decentralization. So the way to achieve the most decentralized network you can is to start with token issuance of zero, right? No one, not even Satoshi Nakamoto himself, had Bitcoin before the launch, right? The At launch day, the issuance of Bitcoin was zero,
Yeah,
and
he was
then,
mining it himself.
but as could we, right?
Yep.
So uh, we I experimented with Bitcoin mining in 2010, around that, and yeah, I could be doing it a lot, and I didn't, so it's my bad, right? But anyone could do it. It was published in Bitcoin Talks forums, right? Anyone could grab that information and decide, "Wow, I'm going to try it out and mine the first million along with Satoshi," right?
Yeah.
So the beauty of that token economics is that it distributes evenly um, during a long period of time to achieve the highest distribution possible of tokens among people, right? And that's the very simple token economics of Bitcoin. It's just that it's a distribution, a reverse distribution of tokens along through time, right? But usually, when you are designing a blockchain, you have a lot more than just the token distribution to think about. Um, there is another aspect of tokenomics of Bitcoin that is still unsolved, and it will be for the next decades, which is, will Bitcoin be self sufficient as a network when the distribution ends, right? And that will only be understood uh, when we are close enough to the end of the distribution. Right now, we still have 1 million Bitcoin to be distributed. It's quite a lot. So when we reach, like, in 3 or 4 or 5 halvings, when there is only just a few 100,000 Bitcoin to be distributed, and we will have a clear understanding, or a more clear understanding of the state of the fees of the network, then we will know if Bitcoin's price will have to really rise a bunch more to make the Bitcoin network sustainable, or if a bunch of miners will be out of business,
Yeah.
right? So that is another aspect of it, of the token economics. And I really think that the value of Bitcoin will be a crucial part in understanding that, because it will have one of the two outcomes that I talked about. Either a bunch of miners will go out of business. The difficulty will have to lower a lot to justify the network to be sustainable when there's only fees, not much Bitcoin being distributed in per block, or the network will grow so much that we'll have to eat all the economic parts of the traditional finance to be sustainable, right?
Yeah. Well, the tokenomics are not only regarding paying for block producing. You can also use tokenomics in order to create incentives.
Yeah.
For the good behavior of the network and the way you want to guide the network. So you guys be aware of that. Tokenomics is quite an important part of your blockchain. So
and we will have an episode dedicated on that because
I think all of these topics do require a full episode dedicated to that. Like we are going to talk next about governance models, which will also require.
We have an episode.
Yeah, but
governance.
we need another one.
Mm-hmm.
Yeah, that's another part. So let's jump now to the governance models. It's also it's not on all blockchains, but some of the blockchains will have this embedded in itself. So you can expect also to have to know how governance models work and what they do. So you want to go for that?
Yeah, we have a lot of examples of core blockchain governance. For instance, if you have to stake, that's a form of governance, right?
Yeah.
In proof of stake, you stake. That's in the name, right?
Yeah.
And in proof of work, you work, right? You have to have computers doing a bunch of work trying to figure out bullshit ashes. Just don't tell this anyone. Don't tell anyone that is a completely wasted search for an hash that is started with a bunch of zeros, right? Because that's what it is. It's trying to figure out random shit.
Well, it's kind of a luck game, right? So you
but it's very cool.
Figure out the solution. You have the solution, and you need to get there, and you need to find a way to get there.
I love the idea. It's due to its simplicity. It's very simple and very hard to find. But that's what it is. Proof of work is trying to find random shit, and it's the beauty of it is exactly that. It's finding random shit is so damn. It's a hard work to do. That's why it's proof of work.
And let's keep in mind that in Bitcoin, that hardness varies depending on specific flags that are happening.
It's very simple. If blocks are starting to become very hard to find more than 10 minutes, then the difficulty adjustment takes in every X blocks, I don't know. And it's like that every 2 weeks it's adjusted, right? So if you start producing less blocks than expected, you reduce one zero.
It's getting too hard.
You reduce 1 0 at the beginning of the hash that you need to find. And that's it. It's so simple, man. It's the beauty of it is that it's very, very simple, the idea, but the outcome is exactly what was the hard part. And Satoshi did it. Kudos to him. or them or her.
Yeah.
I don't know. So yeah, so if you stake, you stake for a reason, right? You stake for an economic incentive usually, and you stake for a governance purpose, which is say to have a say to who produces blocks, for instance, right? That's a governance part, and it's usually used in proof of stake chains. So you have skin in the game. You bought the token, the core coin. I don't like to call tokens to coins in networks because they are different shit.
Yeah.
Uh, so the core coin of the network, you hold it and you stake it in the network, saying, "I will not move this coin. I will not sell it. I am a believer in this shit." Right? It's a form of governance.
Yeah, and it's
In that,
usually called a governance token, right? So
yeah.
that we differentiate for other tokens.
So you besides that, when you do that, you are deciding that you hold that token for a period, because usually when you unstake the token, you have a cooldown period where you don't have the token and you are not receiving the incentives, right? And that varies, but the mean is like 1 month. So you unstake today, in 30 days from now or 28 or something, you will receive the tokens back. But in that period, you will not be incentivized for staking, because you are actually not staking, you unstaked,
Yeah.
and you will not uh, be able to use the tokens because they are on hold. So uh, by having that mechanism, it disincentivized people to be staking and unstaking frequently. So it makes sense to stake what we don't want to move. So that is a form of governance. It's a form of you saying, "I believe the hell out of this network that I will be putting a bunch of money in there, and I'm not moving," right? And with that power that I show to the network, I am able to vote in the network's decisions. And the first decision is who produces blocks. That's the first form of governance that you see on proof of
Yeah.
stake chains. So you say that I want to stake in that validator or a bunch of validators, right? Usually. And that's a form of voting, right? Usually, delegated proof of stake chains use the word vote, and proof of stake chains, not delegated proof of stake, but proof of stake,
Mhm.
usually have the delegation
Yeah.
uh, mechanism, which makes no sense, right? Uh, because delegated proof of stake should have delegation, not the other way around. But anyway, that's uh, people
Yeah.
just find words and usually don't make much sense.
Yeah. The other
Uh,
part of the economic model that you can find there is that sometimes you get some yield when you stake. So that's to incentivize the behavior of using your tokens to be involved in the network decision. So yeah, that's just a small thing that
yeah,
I wanted to
usually,
bring up.
usually when you stake for a validator, when you delegate to a validator in a proof of stake, the validator shares the revenue of producing blocks with you, right?
Yeah.
So the idea is that the validator doesn't have all the stake. So the outcome of producing blocks is shared with the delegators who delegate uh, and allow him to produce blocks or to be higher in the hierarchy of block producers, right?
Yep.
So um, that's usually the governance, the basic level of governance that you get on proof of stake and delegated proof of stake chains, but you can have more and usually have more. For instance, some chains have parameter changes, right? That are governed by voting.
Hmm.
Uh, and usually you vote with your stake.
Yep.
Go figure, right? So as a stakeholder in the chain, in the network, you have a say, saying that you approve a change of parameters or you don't approve, right? And so usually that is done on chain. So it's on chain governance mechanisms, and you can go to the wallet of reference of your chain and vote on the proposals that you think are good and vote against, or some chains use voting against. Some chains consider that if you don't vote you don't approve. I prefer the second, uh, because I've actually I am doing something right now in the chain. I am removing that possibility of voting against, and I am just letting vote for, or not vote. So if you abstain yourself, by default you don't approve. That's it. Because the problem is that, and that's one other thing, that being a core developer uh, is sometimes very hard. Uh, you have to put yourself in the shoes of bad people, right? And if people are bad, doing bad shit, what is the best way for you to counter them, right? Uh, and on chains that have that mechanisms of voting for and voting against proposals, uh, they get a, an attack vector possible, which is if you get a bunch of people with a bunch of stake collude themselves and vote for an uh, a governance proposal, it's very hard to get non-colluded people to vote against.
Yeah.
It's much easier to have bad people collude between them to achieve something that they shouldn't than have a decentralized group of people to come together to vote against something, right?
Hmm.
And this is tried, and the outcome is always the same. It's very hard. It's much harder to vote against bad actors than to vote for good actors. So in that reality, what do we need to do? We need to consider the opposite. We need to consider that all the guys that don't vote, they are voting against, right?
Yeah,
And
mainly what we need to do is to remove the incentives for bad actors to act, right?
that's one way to
Yeah.
remove the incentive. They can collude themselves as much
Yeah,
as they want.
because when
They
we are designing economies, we create a lot of stuff that we think that is incentivizing a good behavior, but we don't counteract that good behavior because we are not putting ourselves in a bad actor's shoes and how they can take profit from that. So what we need to do when we are designing economic models slash governance models is that we need to be very to pay a lot of attention and check a lot of detail in order not to create incentives for bad actors to act, and that's very difficult.
Or at least not allow them to take the best part.
Yeah,
And in this case is exactly what it is, because having a bunch of people colluding or creating um, uh, trying to steal something that they wouldn't normally have access to, it's easy. But the hard part is to get a bunch of stake involved in that, right? When you
yeah,
have a decentralized network with the stake evenly distributed for many people, they can collude themselves as much as they want, as long as they don't have 50 or 51% of the stake of the network. They will
yeah,
go nowhere,
yeah,
right?
yeah, right.
And this is the idea, right? But this is very difficult to understand a priori.
Yeah,
So if you have to always put yourself in the bad guy's shoes. And for instance, a few years ago there was this movement of having blockchains with no fees, right? And that is a very bad incentive for spam, because a small fee doesn't hurt, uh, and it makes miracles, right? Anti
yeah,
spam, anti bad behavior, and stuff like that. I do agree. It's harder to onboard new people with with on-chain fees, because to to do their first transaction they have to have the token, right?
yeah.
And it's another point of friction.
Yeah. But it's
But
not only that. It's even when let's just imagine if you are dealing with the social network on blockchain. Uh, it's hard for users to pay because they are not used to pay for each post that they do. So it's another thing that, and that's why those kind of blockchains came up and those kinds of governance came up. It was so because people are not used to pay for each post or for any content that they put on the internet. So that's a barrier for sure. But there you go. It decentralizes spam.
yeah, but the idea of um, of that model is wrong,
Mhm.
because who is the responsible actor for, let me rephrase this, who is incentivized to get more users to the network? The decentralized apps, right?
Yeah.
So if the problem is that the decentralized apps don't have a good business model themselves. If they have a good
Right.
business model, then they would be the best ones to cover the fees for the new users that they bring to the network.
Mhm.
So that is another incentivization model that needs to be developed, creating good incentives for decentralized apps to operate on chain, right?
Yeah.
And in many chains, including Ethereum and EVMs and so on, I don't see that being developed at all. Uh, dApps continue to have lousy business models. Most of them will fail after the VCs run out, the VC funds run out, right?
Yeah.
Because they don't have a business. They can have a
Yeah.
model. but it's not a
Yeah, it's
business,
not a good one, and yeah,
right?
usually it's not very well thought. Yeah, we need to move forward. Let's just make a little recap of what we talked till now. So we talked about the tools and technologies, programming languages that you will require for blockchain development. We talked about the consensus. We talked about tokenomics. We talked about governance. And guys, if you are enjoying this episode, don't forget to like and subscribe. And if you think that we are moving too fast on each topic, leave us a message so that we can detail if we still have time or find another episode to talk about it. I would like now to move to another thing. So I'm going to close this like this. This encapsulates a very closed system, which is a single blockchain. So all of these are components of a blockchain that you should expect to be developing if you are a core developer. But I would also like to talk a little bit about scalability. Blockchains are not very scalable usually. So I would like to go on the scalability triangle issue and layer twos and side chains, which and how they communicate between them.
Okay. The scalability problem of blockchains is like this, it's called the scalability trilemma, which is you either have on the three sides of the triangle, you have decentralization, you have security, and you have scalability, right?
Yeah.
And you just can have two of them, not the three.
Yeah.
So you have to put yourself in the middle of the triangle. You can put closer to one side, and you have not this other opposite vertex, and so on. So if blockchain like Bitcoin is clearly on the side of decentralization and security, but it's not scalable, right? Blockchains like most of the proof of stake chains, besides Ethereum, because Ethereum is a little bit different, it's more decentralized. But Ethereum itself is not as decentralized as Bitcoin and is not as secure as Bitcoin either, right? Ethereum is more in the middle of the triangle, right? It's a little bit more scalable, but not enough, right? But it's a little bit less secure and a little bit less decentralized.
Yeah, I see it a little
And
bit as those triangles when you are picking up a color and in Photoshop or stuff like
yeah,
that you have the three colors and you have to pick somewhere around that triangle,
yeah.
and so that you pick more or less one of the three
The
colors.
way to be more closer to red, you have to be more less
Yeah,
closer to green and to
exactly.
whatever, right? So that's the thing. So um, that's the way usually this trilemma works. Is that the closer you have to you move to scalability, the less secure and the less decentralized
Yeah,
you get, and that's a reality. It's if you look at the networks that you have right now, um, you can see it very easily.
yeah,
So the most
yeah. So
secure, the most scalable blockchains, Solana, for instance, uh, did I don't know, 3 chain reboots in the last month or something. I don't know.
Yeah. Well, so one way that they try to solve this is by go to the means of having other blockchains complementing the main blockchain. One way to have that, because like that they can stick with security, and they can scale just the same. Well, not the same, but they can scale. So having a layer two will allow you to have faster transactions or more transaction power, so that you don't have to pay this huge amount of fees on the main chain, and
Let's
it will quite solve the problem more or less if it's well implemented.
yeah. The idea of layer twos is there are several types of layer twos, right? There are side chains which
Yeah, kind of,
are
but layer two
completely
doesn't work the same as a sidechain. A sidechain is one chain that it's exactly the same chain with other parameterization. So I want to go to layer twos first.
yeah. So layer twos usually, but even in layer twos, you have two types. There are layer twos that don't have anything. They are called a layer two because they just have a bridge to the layer one, and that's it, right? And there are ZK rollups or rollups in general, which is a different thing. It's actually packing up all the transactions that occur in the layer two and rolling them into the layer one once every X uh, epochs, right? So uh, that means that the layer two chain is also uh, verifiable using the security of the layer one, right? So uh, that's a different approach, which is a lot more secure than the first one, because the first one relies, the only point of connection between the two layers is the bridge,
Mhm.
which you will have the bridge. You will have to have a bridge anyway
Yeah,
to have a layer two. But with the rollups, you actually are able to verify the trustfulness of the layer two using transactions on the layer one to verify it, right? So there is a distinction there. And uh, that's why ZK rollups and all those things are becoming very popular right now, because it's a way to reuse the security of a non-scalable layer one to bring more reliability to a layer two that could simply be very misbehaving protocol, right?
yeah, and usually the layer two is picking a very specific problem of the layer one, and it's solving that specific issue.
Yeah,
So
and the
we
way
can talk, for instance, the Lightning Network. It's focusing really on the transactions
payments, yeah.
of Bitcoin. So yeah.
And for instance,
It's not that Bitcoin has a lot of other problems, but yeah, well, what I'm trying to say is that other layer twos are also focusing on specific
yeah,
issues of the layer one.
and usually what layer twos do is have a worthless token, so that, and the more worthless the better, because even
Yes.
if they get to be very very used, um, it will not make the transactions very expensive, as in Ethereum, for instance. So that's another uh, good thing, which is to also pay less fees. But it usually happens naturally because, yeah, compare the price of Matic with Ethereum, right?
Yeah.
Uh, and it's probably the amount in circulation is much bigger than Ethereum, right?
Yeah.
The circulating supply. So that's it. It's simple math, right?
Yeah.
And that's one form of justifying the layer two, is to save in fees. But then you have hidden costs. What is the cost of parking your Ethereum in the bridge that you don't know how to operate, how it internally operates, and it can be hacked and all that. So,
Yeah. So
well,
so the layer twos are also a blockchain themselves. So if you are going to be a core developer, core blockchain developer, you also need to be aware of this, that you can develop a layer two, which is a blockchain that it's going to solve a specific problem for the layer one. Which kind of differs from a sidechain. A sidechain is usually it can also be used to do this, but it's usually used to implement a full application. And so let's just imagine that you have a new Facebook being developed on blockchain. You would tendentially have a sidechain of some, if not full implementation, but you could also have a sidechain that would be dedicated to that specific application, and then it would communicate what, if needed, or what parts needed, or what transactions needed to the main chain. You want to go a little bit on that?
yeah, that's it. It's a completely different, a completely dedicated chain, right? And usually just plugs into the layer one for grabbing liquidity and for releasing outputs, whatever they may be, right?
Yeah.
It's a completely isolated chain with some kind of bridge in between. It's the basically a single purpose use of layer two that is not rolled, doesn't have
Mhm.
roll ups, right?
Yeah. Yeah. Exactly. So I think we covered most of the things. So what kind of skills are needed to be a core blockchain developer? This
First
is
of
kind of
all,
a wrap up
yeah.
of what we talked
First
about
of
here. So
all, being a blockchain core developer requires you the usual technical skills of a developer. Usually a little bit more seniority than the regular app developer, uh, and requires doing a bunch of tests. Uh, Testing is very important, and I, I I imagine blockchain development at the same stage as developing for aerospace agencies like NASA or European Space Agency or stuff like that, or producing aeroplanes software, or software for automotive, or software for defense or
mhm,
offense,
yeah,
right? Uh, which means that you have to produce very robust software. It's not that the software can fail in the middle of a mission, right?
yeah,
It can't, period, right?
yeah.
If you launch a rocket to point
Except
A,
if you're sending something to Mars.
if yeah, but that shit happens. But shit
Yeah,
happens even if you do proper software development,
yeah.
right?
Which brings
It's
me to
possible.
something because you are talking about testing, and there is a little subtlety about testing, which is simulating scenarios, which you should actually do, and this is a must when we are talking about blockchain development. Is that you need to simulate scenarios that. At least the ones you can't predict that will happen, but try to make some random scenarios which you don't think that may happen, but you need to test for those.
Yeah, testing is very important, and uh, don't find unreasonable to have like blockchain codes being 10% or 20% of the whole codes that you have in the code base,
Yeah,
right? The rest is tests, right?
yeah,
Um, it's usually like that to be properly testing a blockchain, right? You have much more code in tests than you have on the chain itself, unless you have a very complex chain that does have a lot of um, business inside, and that is not very hard to test, which is very uncommon, but can be the case. Uh, you will have much more testing code than you will have base code, right?
yeah, yeah. So you need to code. You need to know how to code in order to become a blockchain developer. You need to know how to make tests, create simulation scenarios. You need to be aware that the blockchain is a closed environment, so you cannot communicate externally to the blockchain. Uh, you
You
need to
need
know
to
about consensus. You need to know about scalability, how to scale your blockchain. You need to know
you need to know about
governance models. You need to know,
cryptography, right? Study
yeah, yeah, of
cryptography.
course, cryptography.
There
You
are a
need to
bunch
know
of
about
notions.
peer-to-peer communications. You need to know about networking, decentralization. You need to know about blockchain interoperability. So these are the kind of things that you are going to face if you are a core blockchain developer. So how
But
hard it is to get there?
but don't get discouraged,
No, no, I'm
because
not discouraging you, right?
because uh, usually people uh, start running away the moment that they see all of these things. But you shouldn't be like that, because there is still plenty of work to be done by regular developers. Not just two junior developers is not very easy, because you will do so much. Uh, you will you will not have the skills to feel well doing any task, basically, in blockchain development, in blockchain core development. So um, what I would suggest you to is to do other stuff. Don't jump heads first in developing core, uh, but you can join your favorite chain and start producing documentation. For instance, start helping out with like the good first issues on GitHub. Start helping out with uh, other tasks that you can find. Join their networks and say, "Hey guys, I am here. There's an extra pair of hands. What can I do?" Right? Don't use the GitHub social network into your advantage. Get to meet people. Offer your services. Offer to be uh, of use to the
Yeah,
core developers.
Yeah, start
because they
helping out, and
they
you
need
will get into the projects and getting
they
involved.
need all the help because they are doing the heavy lifting. And when you get involved helping out in the other tasks around that, you free them to be more focused on the hard parts. And probably by doing that, you will learn a bunch,
Yeah,
right?
exactly.
So that's one form. And the other form to become a blockchain developer, a core blockchain developer, is to build your own.
Yeah.
Then you have
Yeah,
no
well,
restrictions.
you can also fork a blockchain
Yeah.
and start your own blockchain. You don't need to build
For
it from scratch. You can adjust an existing blockchain. You have
or
several open source blockchains
you
that you
can
can pick up.
use SDKs, blockchain SDKs, to start experimenting. They have building blocks that you can put together, like
Yeah,
Cosmos SDK. It's one good resource for developing your own chain and start experimenting with blockchain development. And there are plenty of Cosmos chains that you when after you get a sense of what's involved in that, uh, you can help out other projects that implement on top of that the same SDK that you learned, uh, and you will have a big advantage over other developers that don't experiment in in the SDK itself, right? Um, the other example of that is Polkadot. You can use substrates to experiment with blockchain SDK for Polkadot to create your own parrot chain. And then there are plenty of parrot chains that are live right now, and they need help, and they need people that know a little bit of what's involved in that. So yeah, that's possible. Don't run away from core development. We need core developers. This space is very lonely, uh, because people just find it too hard to
yeah,
begin with. But it's not that hard. It's you just have to have uh, a bunch of skills, but it's doable, right?
yeah,
Uh, if you try to do it all at the same time, probably it's not very easy. But there is an easy path to get in, and that's the path.
yeah. I do agree.
Start helping out. Start getting to know the community. Start uh, be humble. Don't go all in uh, as an expert because you will probably fail. Be humble. Ask
Yeah,
about. Ask instead of imposing your ideas. Ask why not, uh, because usually there is a reason why. You just not see it yet,
yeah,
right? And you will be in a good shape if you with the right mentality and with the right mindset, right? And so basically these are the skills. And if you ask me, is it hard? Yes.
yeah,
But it's doable. Yes, of course it is. I've done it. Miguel, I've done it.
yeah. And a
uh,
lot of people do it, so it's
so
also achievable to you. So
i'm
you're
not
not
i'm
that
not
different.
a guru or a genius kind of guy. It's just give it long enough and you will be a kick-ass core developer. You just need to be there, do
Yeah,
that, right?
yeah,
So
yeah.
the last question is the hard one.
Yeah,
Uh,
how hard this is.
how hard it is to get actually paid for doing
Yeah,
this. Um, that depends, right?
yeah.
That depends because uh,
That's it. That
what
depends.
what what does it mean to get paid? Uh, you can get paid in many ways. If you tell me, can I get a job right away being a car developer? I would tell you no way, because it's usually not like that. There are no job offers for blockchain core developers unless you want to go to the other side of the blockchain development, which is the corporation's blockchain developer,
Mhm.
right? In that part, there are a few jobs, uh, but they usually expect you to have experience in the decentralized part of blockchain development,
Yep.
right? Because to build blockchains for banks, for instance, in R3, um, uh, and stuff like that, which are SDKs to build blockchains, uh, permissioned blockchains for corporations. Uh, Usually, you have to have also the experience of a decentralized system. Or what is a decentralized system? What is a blockchain? What is uh, testing in a very rigorous environment, and all those things that we talked about? So even for those jobs, you will have to have this experience. So, and I personally find much more appealing to work in the decentralized world than the corporate world. But it's up to you to decide. I think both are required for us to achieve mainstream, right?
Yeah.
And I've been working in centralized infrastructure as well. It's not that I just do decentralized stuff, but I think it's more appealing to work in a decentralized project because of the ethos around it. But that's up to you to decide. So
Yeah.
to get a job in this space as a core developer is practically impossible, right? But you don't have to. That's the beauty, right?
Mm.
You don't
Yeah.
have to get a job. You can uh, join a network, put yourself available, do good work, and you will get probably an offer with time, because networks have a bunch of money usually, and they want to keep the best around,
Yeah.
but they will not offer you a job. Then and they will there will be no job description in any recruiter site, uh, because they are not hiring that way. They hire people that contribute first and show what they are capable of. Then
Yeah.
they hire you. Uh, you just have to give time and show what you are capable of first. That's it, right?
Yeah.
So that is one way to contribute to an existing project that you love. And I think that you love is the most important part, because the more you love the project, the more you will have the patience, the uh, perseverance to uh, go against adversity, because there will be plenty, believe me. And the more successful you will be, for sure, the more you love the project, right?
Yeah.
So that is one important part. But there is another alternative, which is do your own shit. And then it's
Yep.
trustless. You don't need any approval. You don't need anything like that. And The odds of you becoming successful are very slim, but you can start today.
Yeah, and it's
And you
very
can do
good
both
for you. Can
at the same time.
But that is a very good way to start exploring blockchain core development and start digging into it, see what it takes, if you like it or not. And you can even contribute if you are forking a blockchain. You can even contribute with patches to the main branch. So yeah, you can start also from there because you are contributing and you are giving something to an existing project.
Yeah, and one thing that I find very important is that you have to put your ego aside to be successful, because and be humble. And I reiterate this. This space is very. If you put yourself in the shoes of the existing core developers in a chain, they are bombarded with people trying to offer them or trying to get from them a lot of shit.
Yeah.
And you will get, when you are in those shoes, you will become harder and harder to communicate with. Believe me.
Yeah,
I've
and
done
the thing
that.
is just like
It's
that. You need to show yourself useful to other people so that they can see you, right? Because it's
if
the
you
way
if you
from
get
you to stand off from
yeah
other people.
if you get to a
Like that.
blockchain core developer asking him what they can do for you, you're fucked.
Yeah.
If you get to them asking them what you can do for them,
And
that's
even
a
better,
completely different thing.
show how you can show how you can help them.
Even better, if you get to them telling them, look, I made this for you,
You want it?
try it out please and see if you like it.
Yeah.
It's a completely different thing.
Yeah.
Just think about having the responsibility that the guys have in their hands, having a bunch of people always trying to get something from them all the time.
Yeah.
And if you show them that you are not that kind of guy, that you first did and then let them know that you did and asked for approval, that's different. You will jump out of the pack
Yeah,
that
you are just saying, here's how I can help.
The pack requires them to help them, and you will be helping them first.
Yeah.
And without requiring anything, right?
Yeah, exactly. Well, this
It's
is a very long episode.
yeah,
I
but
think we can start
it had
wrapping
to
up.
be. It had to
Yeah,
be,
of
right.
course.
There's a
We
lot
need to
of
go
stuff.
through all of this. Let's just go to the chat. We have a couple of questions here.
Yeah.
One from Ashwani. Sorry if I misspelling your name. And the question is, how can we implement CI, continuous integration or continuous development for blockchain applications? And the reply is just like that. It's quite the same as any other applications, with the exception of deployment. As the continuous integration is quite the same, continuous deployment is a little bit different. So the deployment of, for instance, a blockchain, you need to be aware that it's a distributed network. So if you are deploying something, you need to deploy for the whole network and not just for a single server. If you are talking about smart contracts, you need to be aware of key management. You need to be aware of wallets. So it's a little bit different on the deployment part. The integration part, you need to do testing just the same. You need to do building and testing just the same as any other project. Do you want to add anything to this?
Yeah, the security aspects of it, it's what makes the difference, right? In this, for instance, in the case of a regular application, you might the secrets that you should have are like API keys, stuff like that. Uh, and if you get a leak of an API key, you can always reset them and issue a new one, right? And you might get some kind of data leak, but it's not usually a thing of a life and death. In a blockchain project, it usually is, right? If you leak a key,
Yeah.
people's funds are at stake and you will have your project in a bad shape, right? So, a lot more effort in hiding those secrets is required, or uh, using multi-signature
Yeah.
uh, approaches
Yeah,
is
that's what I
the
meant
best way, right?
by wallets and have multi-wallet
Yeah,
signatures. So that you don't depend only on a single approval. You will require more than one approval, so that if there is a leak of one of the keys, the project is not compromised right away, so that you can swap the keys, create a new one, and keep going with your project. So yeah, those kind of difference in terms of security are expected to be very well established before starting deployment stuff in the blockchain. Another thing that you need to be aware of is that when deploying a smart contract, for instance, you need to pay for that. Usually, you need to spend tokens. So, yeah, that's another thing that you should be aware of. I don't recall any other
yeah.
detail that.
Usually, for instance, in the CD part, if you usually have a deployment automated for testnet,
Yeah.
and
Yeah, even for testnet, you need tokens. So, but you
yeah,
can automate that
but those tokens
because you go to a
usually
faucet.
are
Yeah,
worthless, and you can
yeah, you can go to a
do
faucet
that
and get those
automation.
tokens. But even
But
though you need to manage those tokens.
usually the way to go is first you automate the CI part, and then eventually you automate the CD part for testnet, but keep deployments for mainnet manual.
Yeah, yeah, I do agree with that. Yeah, you shouldn't auto deploy for production in any case.
It's very rare to have a project deploying to mainnet automatically, because
Yeah,
humans need to verify the heck out of that
yeah,
to make a deployment,
or at least to have
and
a
usually
manual
several
trigger.
humans are involved.
Yeah,
Hopefully,
at least you should have a manual trigger, like putting a tag in Git, so that the CI can detect that tag, and then it will trigger the deployment on production. But it should be supervised.
yeah, and usually it needs to be signed for multiple parties.
Yeah,
Usually, and
yeah,
hopefully, if the project is decentralized enough and secure enough,
yeah.
right?
But that's the most automation that I would go for in such a system.
If there is a single person that can do a mainnet deployment, then you have a problem much bigger than the deployment
Yeah,
itself.
it's a central. Yeah, it's the same as
Yeah.
the as the centralization problem that we keep talking about. As centralized as the project is, the more the more the less fault tolerance it is. So as you decentralize stuff, you get more tolerance on the process. So I think we can go to the last
Yeah.
question from Mekan. Do you recommend to new programmer to start learning programming from blockchain core or Web3 development? Is it a good roadmap for beginner? I don't think a core blockchain developer is the best way to start. I think the best way to start is contributing to projects and start from. If you want to start coding, at least start from front end or back end development, which is less critical, and you start learning about the concepts of blockchain development. I think it's a better way to start. So, but we also have a good episode to start on blockchain developer. If you want to go back in our episodes and pick that one, we have a full episode on that. Did you want to add?
I think that's core developer is a completely different thing than Web3 developer. And you have to choose what is your thing. Because being a Web3 developer, you can go, as Miguel said, to front end and to middleware, back end, or to smart contract development, and you can do anything like that. And you can start from the easy part, which is the front end and the blockchain connection part and all that. And then,
keep in mind that the blockchain is the foundation for all of those types of project. So it needs to be very strict.
In core development, there is no front end to start with, right?
Yeah.
It's just the blockchain itself. There's no other parts, right? And although you can have an easy path in that we told before, the path is always hard, and you have to choose what is the thing that you love most, right? If you want to build blockchains, then core developer is for you. It's hard, but it's worth it. You have to enjoy the process. Don't expect it to be easy. It's never easy, right? But it's doable if you love it enough. But if you want to build dApps or stuff like that, if you like to interact with users and all that, then core developer is not for you, right? You want to be on the other side, building dApps on top of chains. Then it's clearly Web3 development for you, right?
Yeah.
So it's up to you to decide where you want to be. And if you see yourself building very cool protocols in core development, go for it. Don't be afraid of it. It's doable. It's not just for tomorrow, right? And if you want to be a Web3 developer, you will not be a hireable Web3 developer tomorrow either. Forget it.
Yeah.
Right? You have to do your homework. You have to show yourself in the community, right? So it's the same shit.
Yeah.
Right?
I do agree. Okay, guys, I think we can close this one. Guys, if you stick to us until now and enjoyed this episode, don't forget to like and subscribe. Also leave us a message.
Everyone liked and subscribed, of course.
Yeah,
you don't have to remind them.
Yeah, but I need.
They will like twice, and then they.
I need to say this because it's what I memorized. So.
Okay.
So don't forget
twice,
to like it.
Okay, yeah. Just one is enough.
Yeah. Don't forget to like and subscribe if you enjoyed this episode. Guys, we have social media, so come to us and ask us questions. Give us ideas for new episodes. We also would like to know if you enjoyed this episode or other episodes or not. And if you have any questions out, feel free to ask us.
Yeah. And as usual, thanks for joining us in our mission to decentralize the world.
Wisely.
And see you in the next episode. It's every Monday, as usual. So join us. Cheers.
See you in the next one.
Bye-bye.